On this lesson, we are going to study an example of IP assignment. So suppose that we have this configuration and we need here to assign IP addresses. And we are said that masks must have 16 bits for the net ID. Essentially, the first two decimal values will represent the network identifier and the remaining the host identifier. And also another assumption is that we must start from this network assignment. So we must start from this IP address, right? So first, let's assign the network 1, then the network 2, network 3, and network 4, and then we are going to assign the interfaces as well, right? So since we must start from this here, from this IP address, and we have that the mask is 16 bits, we need to select the first two digits to be the net ID, the network identifier. Therefore, on the network 1, right, the net ID will be this one, 847 and 8. This will be the net ID of this network 1, right? The mask is 16 bits. The network address, remember, needs to have all of the host IDs to be 0. So essentially here, keep in mind that if we have this network ID and here the mask that we're using is a mask of 16 bits, right? Then the remaining 16 bits, because here we have 16 bits, right? So the remaining 16 should be the host ID. This is going to be the host ID. All this is the host ID. Need to be all 0. Okay, so essentially this decimal representation is representing 16 zeros for the host ID. So this is here the host ID of 16 zeros, right? Remember that this is the way that we identify the network address. The host ID with all of the bits set to 0 identifies the network address, and the host ID with all of the bits set to 1 identifies the broadcast address. So in our example, since we have a mask of 16 bits, this address here, in the case that the network address, or essentially the network ID is 10.0, then the network address will be 10.0.0.0, right? Because we are selecting all of the bits for the host ID to be 0. That's why this is a network address, where the net ID is 10.0 and the network address is 10.0.0.0. So coming back to our example, since the net ID is 847.8, then we must select all of the remaining 16 bits to be 0 for the host ID so that we have the network address. So we have 00, right? In the same way, if we want to get the broadcast address of this network, remember all of the bits of the host ID must be 1. So here, remember the remaining 16 bits must be 1, and remember that here each period, okay, separates 8 bits. So this is a decimal value of 8 bits, this is a decimal value of 8 bits. And if we type 8 ones, like this, 1, 2, 3, 4, 5, and then we have here 8. So if we have 8 ones, this is the number 255 in decimal. So here we will have 255, 8 ones, and then also 8 ones in here. So we have in total 16, so 255. Okay, this is now the broadcast address. That's why here we see that the broadcast address is the net ID and then all of the bits of the host ID to be 1. And now the remaining networks is they are all analogous to this. Okay, it is the same idea. Okay, this here applying the same. The net ID now is this one. So if we want the network address, we select all of the host ID to be 16 bits to be 0, and then 16 bits to be 1. So the broadcast address, the same for the network 3, as we can see, and the same for the network 4. Okay. Here, keep in mind that since they specify that we need to start from this address, okay, and from this net ID, then we just increment in 1 the value of this here second decimal place. So the net ID of network 1 is 0.8, the net ID of the network 2 is 0.9, and so on, right? We have here the first decimal place is the same, but since they need to be different because they are different networks, we just change in 1 this value here, okay? You can select also another values if you want. Keep in mind that you have here a very big range of 8 bits to represent these values. Okay, so once we have assigned the networks, okay, now let's assign also the interfaces for the hosts. So we know that this network 1 is this network in here, okay, 847 800, this is the host ID, and the mask is 16. And so now, if we want to here set the host IDs, very simple. The only thing that they must satisfy for this interface for this PC, this interface for this PC, and this interface for the router, remember, the router also needs to assign a IP address for the interface of the router, okay? So the only thing that we must satisfy is that since all these three interfaces belong to the same network one, they must start with this prefix 847.8. They must start with this, and also they cannot have 00, neither 255, 285 on the host ID, because otherwise they will be the network address or the broadcast address respectively. They need to have different values, okay? But very simple, we have a very big range, so we can select. For instance, for this PC in here, we select this value for the host ID, the first 8 bits to be 0, and then the remaining 8 bits to represent the value 10 in decimal. Keep in mind here that this value 10 in binary is this value here, right, of 8 bits. So here we just type 0.10. Now, it is very important that you understand that on this PC here, let's just study this for a minute. On this PC, as we know, the network ID is the first two decimal places, right, this here, and the host ID is this. So this in 8 bits, this 0 in 8 bits is the same as 0000, 0000, right, 8 bits, and this second here, this 10, is the same as 0000, and then we have 1010. So this is now the host ID. Okay, all this value here of 16 bits is the host ID. Is this a valid value? Yes, of course, because we don't have that all of them are zeros, neither all of the bits are 1. So this is a valid host ID. Okay, and now the same idea for the rest of the interfaces. Okay, this PC, now we select this value for the host ID, 0.4.71. You can also represent this in binary. And then finally, this interface also must belong to the network one, so it must be start with 847.8, and then we select here the host ID to be 0.1. Okay, and very important, normally, okay, in networking, when we have a network address and we have a router connected to this network address, if we only have one router, we are going to select the host ID to this router to be 00000 and then a 1 at the end. Keep in mind that this host ID 0.0.1 is precisely this, is 8 bits to be 0, then 7 bits to be 0, and then the last bit to be 1. So at the end we'll have 15 zeros and 1 bit to be 1, so 16 bit in total. This is normally done in the router, okay, management, and also in networking. Normally we select this host ID for the routers. This is also done here and here, okay. Keep in mind, and now if we study this interface, it must start with this net ID, 847.9, very well, and then the host ID we select to be, again, 0.1. 15 bits in 0, and the last bit to be 1. Finally, on this router here, this same router, this net ID, this interface must start with this prefix, it does, okay, 147.10, like this, and then we have here that the host ID is again 0.0.1, which is the same as 15 bits 0, and the last bit to be 1, right? So this is normally done in routers, okay? And now if we have two routers connected to one network, this is the case of the network 3. Keep in mind that normally what is done is we increment in 1. So if here we have 0.1, okay, we now here select 0.2. Now this is not mandatory, this is not a rule that you must follow always. If you here need to assign the IPs, you don't need to follow this route. This is only a convention that facilitates the reading of the networks and the understanding of this IPs assignment. Okay, so here, since we have on this same network 847.10 already chose the value 1 for the host ID 00001. Now for this interface we select 15 bits and 1 bit, so we also need to select 16 bits. However, here, since we have 0.0.2, we will have this number in binary. Okay, this is the 0.0.2 host ID, this is the decimal representation, this is the binary representation, as we can see with 8 zeros. we can represent this 0 and here with 4 zeros, and then we have here the 1 0. Keep in mind that this index in here you can normally use for the binary format, okay, and so on. So this is, since we have 8 bits from 0 to 7, so 4, 5, 6, 7, and since we have a 1 with index 1, we only need to do this, okay, 2 raised to 1, this gives us 2. That's why this value is 2 in here. Very simple to represent numbers in binary. Okay, so now this is just a review of binary representation. Suppose you have this number in binary. This number is not related to the example, just a random number in binary. If we want to translate this number to decimal, we select here the index, 0, 1, 2, 3, 4. We always start from 0, right? And now what we do is, we take all of the ones that we have, we leave the zeros, and we select here with base 2, and we take the exponents. So here, mechanically, very simple, 2 raised to 3, we are going to select because we have a 1 in the index 3, plus 2 raised to 2 also because we have a 1 in here, 2 raised to 2. We are not going to select 2 raised to 4. We are not going to select 2 raised to 1 because we have zeros on these positions. Finally, we are going to select 2 raised to 0 because we have a 1 at this index, at this position. So 2 raised to 1 in this case, right? 2 raised to 1. Now, if we compute this sum, we have 2 raised to 3 is 8. 2 raised to 4 is 4, 2 raised to 2 is 4, and finally 2 raised to 1 is 2. So we have here, well, in this case, this is 2 raised to 0, not 2 raised to 1, because the index here is 0, so 2 raised to 0. And we've computed this sum now is 8 plus 4, and now very important, 2 raised to 0 is 1, any number raised to 0 is 1, and now we have 13. This is the decimal representation of this binary number. If we have this other example, we again put the indices 0, 1, 2, 3, 4, 5, and 6, right? And here we again select 2 raised to 6 is not going to be selected, 2 raised to 5 is going to be selected, 2 raised to 4 not, 2 raised to 3 not, 2 raised to 2 yes, so we just add 2 raised to 2, right? And also 2 raised to 1, so here 2 raised to 1. We compute the sum, we have here 32 plus 4 plus 2, this gives us 38. So this is the decimal representation of this binary value. Okay, this was only a review for the binary representation. Now we keep here studying the IP assignments. We come here to this host, to this PC. It must start with the same net ID. It starts with the same net ID, right? 847.9, see in here. And we select now this host ID, right? The host ID now is 841.22. Right here you can select any host ID values that you want for these 16 bits, okay? You can have any combination. The only ones that you can have is all zeros or all ones. This is the only two that you can use. The other, you're free to use any combination, okay? And this can be generalized for all of these configurations in here. Very simple, right? The same for the network 3 with the IP assignments, and also with the network 4 with the IP assignments of the interfaces. Okay, with this we end this example of the IP assignment. You can download this example on the downloadable documents of this lesson. And now something very important is that so far through the course we have seen masks that are easy to separate, because the separation of the mask, basically of the net ID and the host ID, this separation fall into a period. Now on the following lesson we are going to study complex masks. These are masks that the separation of the net ID and the host ID is not that easy. We are going to study that. This is something that we will